Curious minds, welcome to Curiosity Z. Quantum physics, spooky action, undead cats, and computers from the future. Did you know there are particles in our universe that can talk to each other instantly across any distance? I don't mean fast, I mean literally instant, faster than light could ever travel. Einstein himself called it spooky action at a distance, and it seems to break the very laws of physics as we know them. In 2019, scientists actually managed to take a photograph of this phenomenon for the first time. Today, we're diving into the mind-bending world of quantum physics, where cats can be alive and dead at the same time, and a computer with just 300 quantum bits could process more information than there are atoms in the observable universe. Hey curious minds, welcome back. I'm Alex, and today's Today I Learned episode is going to twist your brain in the best possible way. We're talking about quantum physics, the science of the incredibly small that has enormous implications for our future. Now, I know what you might be thinking. Quantum physics sounds complicated and boring. But trust me, it's anything but. This is the realm where reality gets weird, where particles can be in two places at once, where information seems to travel faster than light, and where the mere act of observing something changes what it is. In the next few minutes, we'll explore three mind-blowing aspects of quantum physics: entanglement, Schrödinger's famous cat paradox, and how quantum computers might someday solve problems that would take our current best computers longer than the age of the universe. Ready to have your mind blown? Let's dive in. Let's start with quantum entanglement, that spooky action at a distance I mentioned earlier. Imagine two particles that become linked or entangled so that whatever happens to one instantly affects the other, no matter how far apart they are. It's like having two coins that always land on opposite sides. If one shows heads, the other will always show tails, even if they're on opposite sides of the universe. This isn't just some theoretical idea. In 1935, Einstein and two colleagues, Podolsky and Rosen, identified this as a paradox that they thought proved quantum mechanics must be incomplete. How could information possibly travel faster than light? It should be impossible, according to Einstein's own theory of relativity. But here's the kicker. Experiments have since proven that entanglement is absolutely real. In the 1960s, physicist John Bell figured out how to test for it, and in 1982, Alain Aspect conducted experiments that confirmed these spooky connections really exist. In fact, these discoveries were so important that in 2022, Aspect and two other physicists won the Nobel Prize for their work on entanglement. The current record for entanglement distance? Over 1,200 kilometers, achieved using China's MISHIS satellite in 2017. Wrap your head around that. Two particles communicating instantly across a distance that would take light about 4 milliseconds to travel. But wait, can we use this to send messages instantly across the galaxy? Unfortunately not. While the particles do influence each other instantly, we can't control which state they'll adopt, so no faster than light text messages for us. However, entanglement is being used to develop unhackable encryption systems. Any attempt to eavesdrop on entangled particles disturbs their quantum state, immediately alerting us to the intrusion. This technology, called quantum key distribution, could be the foundation of all future secure communications. In 2019, physicists at the University of Glasgow did something incredible. They actually captured the first photograph of entanglement in action. What was once just mathematical theory became something we could literally see. How cool is that? Now let's talk about possibly the most famous thought experiment in all of physics, Schrödinger's cat. In 1935, physicist Erwin Schrödinger proposed a bizarre scenario. A cat is placed in a sealed box with a radioactive atom that may or may not decay and trigger the release of poison. According to quantum mechanics, until someone opens the box and looks inside, the radioactive atom exists in a superposition of both decayed and not decayed states simultaneously. This means the cat would theoretically be both alive and dead at the same time. But hang on, Schrödinger didn't come up with this to prove quantum mechanics. He actually created this paradox to show how ridiculous quantum theory seemed when applied to everyday objects like cats. He was essentially saying, see how absurd this gets? The paradox highlights what physicists call the measurement problem, why quantum objects like atoms can exist in multiple states, but larger objects in our everyday world seem to exist in only one definite state. One explanation comes from decoherence theory, which suggests that interactions with the environment cause quantum systems to lose their superposition states extremely quickly. While we've never put an actual cat in quantum superposition, thankfully, scientists have created Schrödinger cat states with atoms, photons, and even small mechanical systems visible to the naked eye. The largest objects ever put into quantum superposition are molecules containing thousands of atoms. It's not a cat, but it's getting bigger. Here's something to keep you up at night. According to the many worlds interpretation of quantum mechanics, when we observe the cat, the universe actually splits into two separate branches, one where we see a living cat and another where we find it dead. Every quantum possibility actually occurs, just in different branches of an ever-multiplying multiverse. So there could be infinite versions of you watching slightly different versions of this video right now. Finally, let's explore how we're harnessing these weird quantum properties to build the computers of the future. Traditional computers use bits that are either 0 or 1, like tiny on-off switches. But quantum computers use quantum bits, or qubits, that can exist in multiple states simultaneously, thanks to that superposition property we just discussed. This means quantum computers can explore multiple solutions to a problem at once. It's like having a mathematical problem with 1,000,000 possible answers. A classical computer would check them one by one, while a quantum computer essentially checks all 1,000,000 simultaneously. In 2019, Google achieved what they called quantum supremacy, when their 53-qubit processor completed a specific calculation in just 200 seconds that would take the world's most powerful supercomputer approximately 10,000 years. Now, the problem they solved wasn't particularly useful, but it was proof that quantum computing works. These machines are particularly good at certain tasks, like factoring very large numbers, which happens to be the foundation of most internet security. This means quantum computers could potentially crack encryptions that would take classical computers billions of years to break. They're also exceptional at simulating molecular interactions. Companies like Volkswagen have already used quantum computing to optimize traffic flow in Beijing, and pharmaceutical companies are exploring how quantum algorithms could revolutionize drug discovery by simulating molecular interactions that are too complex for traditional computers. But there's a catch. Current quantum computers are extremely error-prone due to quantum decoherence. Basically, quantum states are incredibly fragile and can be disturbed by the slightest interaction with their environment. It's like trying to balance a pencil on its tip during an earthquake. Technically possible, but incredibly difficult. That's why quantum computers operate at temperatures colder than deep space, near absolute zero, to minimize disruptions. But here's the mind-blowing part. A universal quantum computer with just 300 qubits, could theoretically store and process more values simultaneously than there are atoms in the observable universe. We're not just talking about a faster computer, we're talking about machines that could solve problems that would be physically impossible to solve with classical computers, no matter how long they ran. Major tech companies including IBM, Google, Microsoft and Amazon are now offering cloud-based quantum computing services, bringing this technology out of research labs and into the real world. The quantum revolution isn't coming, it's already here. So there you have it, the weird and wonderful world of quantum physics. From entangled particles that seem to communicate instantly across any distance, to cats that could theoretically be alive and dead simultaneously, to computers that harness these strange properties to solve previously impossible problems. These concepts might seem abstract, but they're already beginning to transform our world. Quantum encryption could make our communications unhackable. Quantum sensors could detect things we never could before, from hidden oil reserves to early signs of disease in the human body. And quantum computers could revolutionize everything from drug discovery to climate modeling to artificial intelligence. The next decade will likely bring quantum technologies into our everyday lives in ways we can barely imagine now. We're standing at the edge of a technological revolution as significant as the invention of the transistor or the internet. So next time you hear someone say quantum physics is just theoretical with no real-world applications, you can tell them about the photograph of quantum entanglement or the quantum computers already solving real problems today. The quantum world may be invisibly small, but its impact on our future will be enormous. Thanks for getting quantum with us today. If you enjoyed having your mind bent by the weirdness of quantum physics, be sure to hit that like button and subscribe to our channel. As always, keep questioning, keep learning, and stay curious.